Hello and welcome to Dare to Know, interviews with quality and reliability thought leaders. I'm Tim Rogers, and today we have a special interview recorded by Fred Schenkelberg. Fred's guest was Ryan Van Fleet, product engineer at Relyence Corporation. Ryan attended Penn State University where he studied computer engineering, and he's taken his knowledge of software to the reliability engineering field. His introduction to reliability engineering was as a quality assurance analyst with Relyence Software Corporation, which was later acquired by PTC. Later, he took a position as an IT project manager with General Electric's Transportation Division, where he implemented software solutions to locomotive manufacturing quality, field reliability, and field maintenance analytics. Ryan next joined the team at Relyence, working in software engineering for their reliability prediction product, and then accepted his current role as a product engineer to help define and deliver the next generation of Relyence reliability and software quality tools. Let's join Fred's interview with Ryan Van Fleet.
All right, welcome to Dare to Know. This is Fred Schenkelberg, and I'm talking to Ryan Van Fleet from Relyence with a Y. Remember the show Car Talk?
No.
Have you ever heard that? It's an NPR show. There's Click and Clack, the Tappet brothers, these two guys that would talk about car maintenance.
Okay.
And it was a call-in live show, and if a woman called, and I was just talking to Kelly Snyder, and I mentioned it to her.
Yep.
And I said, if you ever called that show, they would definitely ask, Kelly, huh? Is that with a C, with a K, with an I, with an IE, a double E? So what's the Relyence is relatively new. I'm not familiar with it. I had to ask what you guys did and where it came from, but the Relyence with a Y, I would have probably pronounced it differently, so I'm glad I asked. But where did that come from? Where did you guys start?
So about 3 years, so we were about 3 years old at this point as a company. And how we started is the original founders of Relyence, who are Kevin and Eileen. They were the original founders of Relyence back in 1986.
That's right.
And then
That's been around a long time.
It's been around a long time, exactly. And then they ran it until about 2010 or so, 2008 probably. They sold to PTC, retired for 5 years, enjoyed that for a little bit, but then decided to come back into the game, start Relyence, which is really a direct competitor with PTC now. And
was it a 5-year no-compete clause in the sale?
It was a 3-year no-compete clause.
But they enjoyed the vacation part of it.
They enjoyed the vacation, made some trips down to Florida, and so got to relax a bit. But then decided to get back into it, and really with the idea of taking all that knowledge that they had for those 20 years, but being able to start fresh, start with something new, and not have to bring all that baggage from 20 years of software that everyone's used to, and then make something new for everybody.
Well, you mentioned that you're in the computer science realm.
Yes.
Not necessarily a reliability guy.
Yes.
I won't hold that against you. But the starting fresh, the tools today are completely different than 20, 25 years ago.
They are. Yes, the tools are completely different. A lot of them have the same ideas. They'll have, like, if you're looking at prediction or FMEA, they'll have new standards, same ideas, new standards, but then some of them, are completely new or completely different than what they used to be.
Well, I'm talking even the computer science end of the tools.
Oh, that's totally different, right? Relyence was all C++ based, installed on a laptop. We're all cloud-based, built on Microsoft Azure.
Okay.
And then so it's completely hosted in that environment, and there's no, you don't install it on your computer or anything, and it's all web-based.
Well, I'm seeing more and more software doing that. And I'm looking at a package for project planning that's all web-based. And I realized one of the downsides of that is that on the airplane, I can't do as much. And so I pulled up my tablet, which had the ability to locally edit, and then it would sync later. And I was like, okay, they need to put that on the desktop,
right?
The ability to sync, but it comes through a browser, so it's a technical problem.
Yep.
Now, how about Relyence? You see the site and PTC. I don't know what they're using, more generic graphics. So I'm not sure where they're aiming the software. But Relyence was kind of the military contractor type package. They can't even attend a webinar on WebEx because they at work because of the security risks and so on. So how are they going to be able to do a fault tree diagram on a cloud-based system?
Right.
Or is that not the market? Maybe you're going after something else.
And so originally that was not our market target, but kind of what we found is, so we came to Rams last year and came with this just cloud solution, all hosted by us. And what we basically found out is a lot of people here were just immediately can't use it for that same reason, because they can't.
Well, even in commercial companies, it's well, I don't want to send our dirty laundry essentially
outside. Absolutely. So what we did is we actually went back after last year, and we now have a version that can be installed on a Windows server, any Windows server, or even Windows laptop, and then you can install it with the idea of a company installing it in their own cloud.
In their intranet.
Their intranet, they install it there, and it runs the same, but you're not talking to the outside internet.
That's right.
You're just talking to your own server.
A little bit different realm for updating and keeping the software current. You have to have a port that you can access it, or they may initiate the updates.
And that's the way we're going now. Is the nice thing about our cloud one is we can just update it in the background and you see it, but with now we have versioning and all that, and we'll work with the customers, do WebExes to run them through the update process and everything. And so it's been going well so far.
That's cool. That's cool. So what's in the suite? And if you say prediction, I'm going to say why.
Yes.
But, so let's start with that. I'm sure. I mean, Relyence was just. That was the cornerstone package. That was the entry package for most people.
Reliability prediction.
That's right. So prediction is the parts count, especially the 217 based one, is just, we know that it's horribly inaccurate and it gets misused where people think it is a prediction of future performance.
Right.
Right. What should people be using predictions for?
So we do have the reliability prediction package. And our whole reasoning for doing it is because a lot of groups, that's a requirement. A 217 prediction, if they're doing a contract for Department of Defense, that's a checkbox that they have to say, yeah, we did it. And so we support it and we can do it. And I think there is value to them. They shouldn't be taken. A lot of people like to take them as a truth of fact.
And it goes on their data sheet. And wait a second. Yeah, that's not.
And it's not. It's okay. And kind of what we're trying to do is we're trying to integrate all of our tools together. So we have our Kappa, our Fracus tool, and with that tool, we'll calculate if you put in some time information of how many things you have running out in the field. We'll give you your actual failure rate, and then you can compare that to what prediction gave you to see, okay, are we close here? Is prediction totally off? And then you can start to try to either refine your prediction process, or then maybe there's something that you didn't account for happening in the field.
Well, after, many products are generational and family based and so on, so that then can inform your predictions. Is there a facility to do that, or do you?
So that's what we're trying to do right now. So we just put this integration in the last 6 months, and we got it first connected. And so we have the information flowing from prediction to Kappa.
Right, and then you can compare them.
You can compare them. And then what we wanted to start to try to do is go back the other way, send Kappa data back to prediction, but then also allow you to do like a mixture failure rate where you're doing partial predicted, partial actuals to get a more accurate failure rate.
Right. Yeah. And I warned you, I have my no MTBF coffee mug here.
I saw that.
Yeah. One of my, years and years I've been talking to the folks at Relyence and saying, why are you publishing, or the output of the prediction, for example, and many of the other tools was MTBF.
Yep.
And I said, why? We know, that it's a relatively poor metric. It doesn't really inform the user what's going on or what's the trends, or it's so. And the other part is it's so often misunderstood. And you've heard that where it's a failure-free period,
or throw around MTTF and MTBF. They say they're the same thing, and you get a bunch of.
It's just I think even if it's used completely properly, so many of the people that interact with that metric really don't understand it and don't understand how it's used. Why not provide a a probability distribution or a CDF plot or a reliability or availability metrics instead of an MTBF value?
Right. So I'd say that stuff is on our roadmap of what we want to do, specifically around calculating availability, giving you other ways to sort of solidify how valuable that reliability prediction is. We're just not yet at that point of having that implemented, but one of the routes we're looking is to give you more calculations around that, give you reliability block diagrams, to give you more tools than just this 217 prediction that's been around for 20 years and hasn't been changed.
There was some work a few years ago about updating the revision and getting more physics of failure type models behind it instead of tabulated data, which is very, very hard to get anymore.
Right.
And Telcordia has been struggling to get data. Many of the other standards have been struggling to get information.
Yep.
So is that on the roadmap to go after the physics of failure type approach?
Yeah, and so specifically with Telcordia, that's one we're looking at hopefully starting work on like in the next 2 months.
That's still, they're still struggling with collecting the right data and stuff. I'm thinking of going more, we have all these different models for, component failure mechanisms and rates. It generally doesn't include the early failures though.
Right.
And so the databases theoretically capture the mix of failure mechanisms. But the tool and the software behind it makes, like CALS and DFR Solutions provide physics of failure modeling and tools. You've got a much bigger audience and potential, and it behind the scenes it's a little more sophisticated calculation.
It is,
but it's just a formula.
Right.
But how about like things like Monte Carlo and so on, where you end up with an output of a distribution.
Right.
Rather than
the flat line, the MTBF thing that reliability prediction gets you.
So from a computer science side, that's not impossible to do.
Absolutely not. No, right. You need some more high-level math.
Well, how about things like Raptor and BlockSim from Relyence, right?
Right.
Where the block diagram, the blocks themselves can have the whatever distribution.
Right. And so that's something that, because BlockSim especially is like sort of a combo of fault tree and RBD. And so right now we do have a fault tree module, which sort of starts to get into that realm. Our fault tree module, we still have some more additions we want to make to it, but it's at least a solid starting point. And then especially if we add reliability block diagrams to it and sort of can get those sort of, the distribution type things, the more complicated math. It's harder to set up from a user standpoint. You need more knowledge, but it ultimately provides you more accurate, more reliable data. And it's more useful.
So I still haven't got the answer on why MTBF though.
Why do we still have it in there?
Why is it even? So it's a chicken and egg problem. If the primary software vendors are providing MTBF, then that just reinforces the need to use it.
Right.
Because that's what I have. Right. Where if you would have provided reliability or availability or uptime or a handful of other metrics that come out of distribution type work, it wouldn't be the default.
Right, and at this point, our reason for having it is because a lot of the times it's a requirement from our customer that they need to have these 217 predictions with MTBF to be able to give back to their customer to support it, which ends up being our driver.
That's right, and I've heard that before. It's that you're meeting the customer's request. So what role do we have in educating the customer? Is whether it's me on a podcast or webinars and here at the conference of papers and technical stuff or professional societies and standards, right? And then software, you're trying to fit into that realm. Do you take a leadership role in educating your customers in some realms?
Yeah, and I know a lot, and so we're relatively new to this whole, this is our second time at Rams now, and I know something that we would like to get into, hopefully even as early as next year, is especially with the tutorial sessions, being involved in actually running them. So then we're showing that we're being the leaders in how it should be done, how it should be used, and also providing you tools, but then also guiding you along the way of doing it the correct way, not just checking a box to say, hey, yep, we did an FMEA.
And that tells you this. Somebody will buy the prediction because it makes it quick and easy, and it's not painful to do a prediction, and they can check the box. Yet as well as I do that That doesn't help the customer. It doesn't help the people that are receiving the prediction.
Right.
You know, it's kind of a waste of time, to be frank.
Yeah.
To a large degree. And I've had that happen where it was a condition of sale. If we don't send them the document with the prediction, they won't send the check.
Right. And that's how the world is now. And hopefully we can either, I don't know if it's a new standard that has to be made or just totally different from reliability prediction, but hopefully we can start to transition to that way. But now it's part of our world, and there is still value in providing a rough guide of what's going to be what components are going to be have more failures than other ones.
Well, that was one of that first prediction I did, and it was really just an exercise for me to know what a parts count prediction. I got about 10 minutes into it, and I went down to my boss and says, "What? How does this make sense?" And it was Dick Moss, and he said, "It's the actual number you get is not terribly useful in any realm, because in theory, if you have really good component information failure rate or subsystem failure rate information from your designers, from your products, from your customers, it theoretically should line up pretty well."
It should.
And I think the theory is fine. He says, but it really doesn't connect to what the actual performance is. And I think even 217 says in the document, don't use this to predict future actual performance.
Right, because they assume constant reliability the whole way instead of doing there's no end of life type stuff. Yeah.
Right. And I said, well, why are we doing it? This is ridiculous to do it just for a checkbox. What are they going to use it for? And he said, I don't think they actually use it in this particular circumstance. It's just somebody thought it would be a good idea, and they added it to the contract, and for this program it doesn't make sense. And so he said, but it helps your design team use less parts. You add parts, the prediction gets worse. Right. It's just
with
sheer numbers. Yeah, it's just how it works. And he said if you keep the electronics cool, it reduces the failure rate. Because a lot of them are based on an Arrhenius equation, and so he says it helps your team have the right behavior concerning reliability. Fewer part count. Keep it cooler, and some of the other factors that the prediction is as they make changes, they can see the reflection of what it does. And then comparing different architectures, comparing different concepts. You can put together a quick prediction and compare them. Another view I've seen is what surprises a lot of people is they go, we have that many capacitors in here?
Right.
And even though individually they're really pretty robust,
but you add in
1,000 of them, and all of a sudden they're the block that's going to cause problems.
Right.
By the way, capacitors, connectors, and power supplies keep reliability people in business because they're just they're horrible.
Yeah, and that's something that that's another thing that we tried to do. So we have a feature called dashboards, and so one of the things that lets you do with reliability prediction is it'll plot your failure rate from 0 degrees Celsius to 100 degrees Celsius and give you a nice graph so you can see that, okay, at 10 degrees Celsius and 80, we have huge spikes in our failure rate. And so then it'll give you that incentive to, keep it cooler, keep it in a certain range as opposed to taking our failure rate is 57 failures per million hours.
Period.
Something like that. End of the story.
Yeah, well, you should check. My paper got pushed into the poster session near the end of it, but it's on exactly that concept. It's using the derating guides instead of a 0.40, 50% derating for a capacitor for voltage. It's what if I change if my applied voltage is 48% or 30% of the rated voltage, or here,
what happens?
It changes the stress changes, so my expected failure rate should change. Right. And that's way more informative. I'll have to take a look at that dashboard because I think that's in the realm that then you can inform people to make good decisions.
It's neat, and it does. We do right now. We have on a temperature You can set 0 to 100, you can set all that, and also based on the different environments in the 217 handbook. So then you can see, if it's just on the ground versus in flight, in space flight, you'll be able to see the different failure rates. And that one's
kind of informative.
That
That's
one's
fun
just
to play.
mostly cool because there's one called Cannon Launch, which always has a massive failure
Spike,
rate.
yeah.
Exactly. That was kind of funny.
The guys doing oil exploration, when they put some sophisticated stuff down into the borehole when they're exploring for oil.
Yep.
And that's a harsh environment.
That
I thought
is.
Cannon Launch was bad.
There's some bad ones.
There's some bad ones out there. One of the tools to think about is moving that into the derating part. Is I'm picking some suppliers and vendors, and I get their max rated voltage, and I know that I'm at a 10 volt or 5 volt rail. I can start putting in, what's that relationship between how do I derate this? What's the proper derating line?
Right.
Because you already have all that information.
We do.
Use that
Right.
dashboard kind of idea and show that curve.
Right. It's a bit more equations than what we have today to derate that information into account to then give you those sort of stress. Hey, I'm only using at 10 volts when it can be used at 50 volts, whatever that case is.
And it's a trade-off then, and oftentimes they're doing so instead of waiting to the design or the bill of materials available, which is typically when we do a prediction,
Right.
is move it up into the design process.
Start it before you've built anything. Have it really planned out, and then you can make it better. You can just put in, all right, we have 100 capacitors, and then get you a rough idea.
That's right.
But then as you know more, then you can put in more specific data and make it more accurate. But at least you have a baseline to start from.
That's right. Well, let me switch gears here. We'll wrap up a little bit. Does Relyence offer like webinars or training and things like that?
Yes, so we do. Actually, I do myself.
Okay.
So I typically do 1 hour WebEx demos with customers on any or all modules that they're interested in. We'll do follow-ups. We'll come to your location and do trainings. Really kind of whatever they need, we want to make sure we're
So is
doing.
the training based on, how to use the software kind of stuff, or is it more how to apply reliability techniques?
It depends on our customer's knowledge. If it's someone who's already very familiar with FMEAs, for example, we're not going to walk them through the theory behind what every column is in the FMEA worksheet.
Right.
We'll just walk them through, hey, this is how you do it in our tool. But a lot of times we do have customers who will take them through our process FMEA. We have a pretty robust from process flow diagram to PFMEA worksheet to control plan. We'll walk them through the theory behind it, so then, because data will flow between each of them so they can understand how to do it efficiently, and then it'll give them an accurate result that they're doing correctly using our tool.
Okay. Yeah, we'll have to talk. I'm putting together a professional development site. And there's some of that, not how to use your software, but
how to use the tools.
how to use the tools, and you happen to be using that software.
Right, because at the end of the day, they all are involved in the same basic goal. And then how you get there, hopefully we can make it better.
That's right. All right, and so what's the best way for people to get in touch? If you're here at the conference, which they won't hear this podcast except for the guys in the background.
Right, exactly.
Is you have a booth there and bright white shirts and smiling faces and all that good stuff. Well, what's the best way for people to get in touch with you?
Yeah, so our site, just relyence.com.
Okay, with a Y.
Relyence with R-E-L-Y-E-N-C-E.
Right.
There is right on there, right at the bottom, there's our phone number. If you call that and hit 1, you'll get our sales team. And then we have an email address, info@relyence.com. Either way, we'll get your questions, anything that comes in.
Well, that's cool. We'll appreciate that. I'll put some of that information up on the show notes and the links and stuff like that. And I'm sure we'll be talking some more, especially about some of the training type stuff and things like that. That'd be really cool.
Yeah, I appreciate it. It's always fun to talk to people about it.
Oh yeah, exactly. All right. Well, thank you very much.
Thanks, Fred.
All right.
Yeah.